So this is the right direction. Okay, sounds good.
The rush. Okay. Maybe just here. Pick up the just bend that. Then we'll have the
Okay. Yeah, this should be okay. All right. Hello. Yeah. When you start the stream, yeah. Sure. We can start now. Right? Yeah. Okay. Let's just try to stick with the schedule. We said we would start at 6. Yeah. Oh, did I say that? No, I'm sorry. Okay, we can wait. I forgot. I'm doing.
Thank you.
Okay, just so you know, I'm doing this thing. So Okay, so let's start. Welcome everybody to CJOG tonight, and then we have Temporal and also improving, sponsoring this very beautiful place. Thank you. Again, we are going to have Peter Sullivan from Temporal doing a talk on Saga pattern. And let me start. First of all, we're going to run a raffle of 2 JetBrains licenses, like we always do. So if you have won something within the past 9 months, you're not eligible. However, if you are interested, even those online too, you are welcome to enter into this raffle. But we'll also check to make sure that you haven't won anything within the past 9 months. So, and I can share this slide deck afterwards too, in case you miss it. Okay, and just some housekeeping. Please start using Luma. We have a new page now on Luma, that platform. If you haven't already used it, it's actually quite easy too. We'll be sending out the Luma link, and you figured that out. Yeah, just register is quite straightforward too. And we will still continue to use meetup.com, but we'll be slowly phasing that out. Probably by the end of the year, we will stop using it. And then we also have the Chicago Tech Slack. If you haven't already joined, the link is there to join. And then Freddie Gimay, the previous CJUG leaders, and he's now in Expedia. So he continues to run the Java Off Heat podcast. So please join if you like. Also, we are on Mastodon, and we probably will add in other, like Blue Sky, for example. We just haven't got a chance, but now that Logan is coming back, I can have Logan help me with that. But yeah, for now, if you want to join us on Mastodon, we have account on fuj.social. That's if you are not familiar with Fuj, but please use it too, because it is like a really nice place for all centralized, like a giant Java repository place. It's replacing the previous java.net site too. And it's maintained by Yergan, who's working for Azul, and he's based in Netherlands, but then it's like international. So please, follow us on there and follow Fuji. And then we're still on Twitter or X if you want to follow us there. And we're on Discord if you haven't already joined us. And for every Discord or every event, we'll create a special room for that. So for tonight's, there's this room. It's always labeled by the date and then also the topics too. So tonight's is 2025 0611 Sagas Temporal. That's the room. And then Peter, you're welcome to join it to have further conversations around your topic. So. Some community info. JetBrains continue to be our sponsor, and they are sponsoring us 2 complimentary licenses. That's what we're raffling off every month. And there's also a itjobs.us. They have job listings from all over the world, including the US too. So, upcoming events. So in July, we are trying to now confirming the space, and most likely we're going to do a lightning talk meetup. So if you're interested in presenting like a 5-minute to, well, 8 minutes, that's fine, 5 to 8 minutes short talk, and that's the goal of it. Any kind of topics, it can be Java, JVM, Kotlin, anything. And then now too, because we haven't been getting as many people signing up for it, I'm going to also invite the AI Collective Chicago. That's another meetup group. They are focusing more on AI, but I think it's also a good opportunity for us to be collaborating with another group, especially in AI, that space. So that group will have tons of people. I'm already anticipating quite a few people will be submitting their talks. But then here too at CJUG, I like to also see some folks submitting your talks too. And we won't decline anybody unless your topic is really off somehow, but I don't believe so. And then we're going to also offer like a practice session if you feel you need it. So it will be myself and I've talked to Logan and also with Jerison too. We can be helping you out and just to improve your presentation, so to speak. So okay, and then the next meetup too after that will be on August 19th, most likely, and that will be with Francois Martin, and he's from Switzerland, and he's a speaker. He works for a consulting firm that's based in Switzerland called Karakun, and he will be speaking at the Kansas City Developer Conference in August, and then he's asking to visit us, and which we really welcome because he will be coming from far away, and we want to welcome people from overseas as well. Okay, so just mark your calendar for that, and we'll be putting up the event soon, as soon as I get information from him. And then in September, we have already confirmed with Gerrit Grunwald, and he's a developer advocate from Azul. And he came like 2 years ago talking about crack too. That's the what is it called? Like a check recovery coordinator. Yeah, that's right. Thank you. Okay, thank you. Okay, so yeah, so that should be fun. I think he should be talking about something about JVM on that topic too. He hasn't given me the topic yet. Okay, and then we have other confirmed speakers, but we're probably will be doing with them like online because they cannot travel. It's basically from Oracle, from the developer advocacy team, Alina, who's working on the GraalVM, and also with Josie Pamalt, and he's based in France, and Alina is based in Switzerland, although she's Ukrainian, so just so you know. And then we're still trying to see if there are enough interest. We can do an unconference style meetup too, which is like everybody vote for some topics and we can be, have form small teams to talk about things. So if you're interested, let me know. And if you're interested in speaking at CJUG, we always welcome you if you can send your topic or proposals to present@cjug.org. Also, if you're interested in doing lightning talks, if you just want to talk about whether you should talk, to do a presentation, feel free to, and feel free to reach out to me and any one of us here, Jay or Logan too. And this will be again for July 24th. Okay, and then if you are seeking jobs or if you're recruiters, if it doesn't look like so, you're welcome to join our CJUG group on LinkedIn to get connected there too. Okay, and now we'll go into the sponsor section, and we want to continue to thank Neo4j, who is our silver sponsor this year. And also, if you're interested in entering into their monthly raffle, I don't know if they will be raffling off a drone, but something like that. It should be something fancy like that too. So please feel free to scan that, and then they will have somebody reach out to you when they do their monthly drawing too. So, okay, I see someone taking picture. Okay, if you miss it, let me know. I'll share with you the slide deck. Okay, now we want to thank you to our sponsor, the venue, beautiful venue from Improving. So we have Russell in here to say a few words about Improving. Thank you. Yeah, thank you. Yeah, okay.
Welcome, everybody. I recognize some familiar faces here. It's nice to see everybody. As a lot of you guys know, we are very involved with the Chicago technology space. We run these events all the time. If you'd like information, you can sign up, scan that. We do blogs, white papers. We have a Flink event that goes around data movement, uses an open source Flink coming up. You can sign up for that. That's a free event. And as we go through, the most common question I get is, all right, what does Improving do? Aditya just asked me that earlier today. And so we are a multinational IT consultancy, and we help clients solve their most complex technical problems. And that takes a lot of shapes. We can do everywhere from outsourcing. We can do that to providing subject matter expertise. We do that for very large engagements. Like we're right now helping Costco with their migration to Google on the cloud. I'd just like to thank Mary for making today possible, all the work that you do, for Peter for providing the content and having everybody here, and your guys' participation. So I'm happy to talk to anybody, asking if you have any questions afterwards. But again, you can find your information. We're here as a resource for you, and love supporting the community. Thank you.
Yeah.
Cheers.
Thank you. Thank you, Peter. Not Peter, Russell. Now with Peter. Although, let me go to the next one. Now we want to thank our event host, Temporal. And did I say it correctly? That's the way, right? Temporal,
yes.
right? Yeah, I just want to make sure. Okay, so do you have anybody in here wants to say a few words about Temporal too?
Yeah,
Oh,
I mean,
you can say. Yeah.
yeah,
Okay.
of course. Well,
Yeah.
thank you all for coming. And yes, the pizza and food sponsored by Temporal, the team that I work on, um, obviously is hosting the event here tonight. We're really glad that you all came. I'll be speaking obviously in depth about the technology. Temporal is an open source company that provides a solution for durable execution of applications, but we'll get all into the technical weeds. You guys will learn about that as we go. But yeah, we're happy and thankful to Mary for letting us participate in the CJUG and for Russell as well in the partnership with the improving team. So thank you both.
Thank you. Thank you, Peter. Okay, so just a couple more slides and then you'll be up. Okay, we want to also acknowledge friends of CJUG. These are user communities, the worldwide Java community, and in particular, the Atlanta JUG in Georgia, Boston Java user ACM chapter in New England, Garden State JUG of New Jersey, Kansas City JUG, Missouri, New York Java SIG in New York City. They are the oldest Java users group in the US, and Pittsburgh JUG in Pennsylvania, Portland Java User Group in Oregon, and Virtual Java Users Group. And they're based in London, but that's virtual. So they do a lot of virtual events too. Okay. Okay, some news too. This one is actually, I have to thank John Burns who added in this section, but wanting to share with you. So Java just had the 30th birthday on May 23rd. So there's also a link to the live stream if you're interested, or you can search online for Java, that channel. They have the recording too. So that's pretty good too, because even with James, yeah, he got the father of Java, right, James, and that was a very nice interview too. So I suggest you, if you're interested, look that up. And then Spring 7 and Spring Boot 4, these are major versions that are coming up soon, and also the specify adoption. And Spring and JetBrains. So JetBrains have partnered with Spring. JetBrains have partnered with Spring to push backend Kotlin support forward. So that's the link to it if you're interested. There's a blog post about that. And Kotlin 2.2. So there, if you're Kotlin users are coders, then you'll find that there are new guard conditions in when with subject, multi-dollar interpolation, and non-local break and continue, and context parameters in beta. So these are new features. And K2 is now default in IntelliJ too. Okay, so those are the news. And now we'll have our speaker from Temporal, Peter Sullivan. He's the Senior Manager of Solutions Architecture. And also he has very extensive consulting and solutions architecture experiences at major companies such as VMware and Pivotal. So welcome, Peter. The stage is all yours.
All right.
Okay.
Thank you so much, Mary. That was awesome.
Thank you.
Super informative.
Yeah.
I'll have to read up on some of those news items. That was helpful. Yeah, for
Okay.
sure.
All right, cool.
And again, thanks, Mary. Thanks,
Thank
CJUG.
you.
Thanks, Russell, and Improving for having us here tonight. And so tonight we'll be talking about the Saga pattern in Java, and we'll be talking about Temporal, which is a durable execution solution. Mary just touched on a few of the things about me. Just to round that out very quickly, I am a solutions architect. Well, I manage the solutions architecture team at this point at Temporal. Been with Temporal for about 2.5 years or so. Been working in the IT industry for over 20 years now. Everything I've done has really been focused on application development and software engineering. All of my individual roles as a developer myself, an architect, wore a little bit of a security hat in application security for a little bit of while. Have worked with a number of companies, both located in Chicago and outside of Chicago. And of course, I'm on LinkedIn and happy to connect with anybody there if you're so inclined. Want to learn a little bit about you in the context of tonight's conversation. How many of you are working on building back-end applications? Good number of folks in the crowd. Have you worked on systems where you have to implement transaction management within those applications? Cool. Folks already familiar with the Saga pattern? Have you heard the term before, used it, implemented it? A number of folks here as well. And how about Temporal? Anybody have heard or used or played with Temporal? A number of folks as well. That's great. So those, of course, are the things we'll be chatting about today. I'm going to put this presentation and we'll go into demonstration. We'll see plenty of code to scratch, the nerd itch we all have around that, but in the context of an example business process. And so, something that we all probably have done in our lives, booked a trip through a travel website. The trip consists of, booking a flight, booking a hotel, booking a car, and then maybe processing a payment for that trip booking. So in this case, it's a fairly simple business process. There's 4 steps that need to execute. In this case, we'll execute them or design the execution of them to be fairly sequential in order. But obviously, our desire is to complete all 4 steps successfully to satisfy, our customers who need to book trips, ourselves who are booking those trips, and the company, the organization, ostensibly providing this application. If I'm going to sit down as an engineer and maybe take a simplistic approach to implementing this in code, I might think about the book tripping application running as a single process, a single app on a single node, maybe storing some state in a single database. Maybe that state is related to each of those booking operations. And so in Java, there's lots of different transaction management libraries. You may have your own, your favorites. I very simply took core Java here versus Spring or anything else. But we have the opportunity to begin a transaction in our Java code and execute a number of sequential statements within the scope of that transaction before we close that transaction. And so we do so by turning off auto commit for our prepared statement execution. Again, constructing our prepared statement to do the flight booking, execute that, followed by the hotel booking, execute the car booking similarly, and then collect payment. And at the end, we commit all of those operations to the database in a single transaction. And the database guarantees us those ACID properties of the atomicity, consistency, isolation, and durability of that transaction. And we know we benefit that if something goes wrong in the execution of this code, what we get for free from our database implementation, through the Java code or the Java abstraction here, is an automatic rollback of those first 2 operations here. So the scenario where maybe the car booking through the database statement that we execute for that car fails, that bit of the transaction or that write or update of a database table is not successful. Well, then the prior statements that have been executed in the context or in the scope of this transaction are automatically rolled back, right? And that's super nice and convenient for us when we're working in a single database. We get, again, that holistic transaction management for free out of the box. However, our world is not that simple today, right? We're very rarely operating and building single applications with a single database in a monolithic style. We're distributing the components of our applications as microservices for higher scale, higher availability, maybe higher reliability of those. And each of those individual services might be working with their own independent data store. And so to now execute this end-to-end process, we have a series of local transactions. To book the flight, we have our Java code or snippet of Java code, which will prepare that statement for the flight booking against the flight booking database and execute that bit. For the hotel as well, that's going to be an independent execution of that SQL statement against that hotel database. Likewise for the car, likewise for collecting payment. And of course, in the real world, these may not all be database transactions, but just for the purpose of conversation here, we'll assume that they are. And the challenge with this is, of course, now we're dealing with a series of local transactions versus one kind of global end-to-end transaction. Is if this car statement fails, if we're unable to book that car, well, in the sequence of transactions, we've already booked the flight and we've already booked the hotel. So what is the overall end-to-end state of our business process right here? It's inconsistent, right? We've booked half or 2/3 of the operations in terms of the flight and the hotel. We failed on the third, but we don't get that nice simplicity of our database transaction rolling those things back for us, right? So we now, as engineers, as software developers, we got to figure out what to do with this ourselves. How do we drive consistency of this end-to-end business process? And so that's where the Saga pattern comes in. And most of you know this already. There are the majority of the hands went up when folks are familiar with the Saga pattern. It is a pattern for failure management in distributed applications that we apply to coordinate transactions between multiple microservices to maintain that data consistency. See, it's a pattern we can apply to get us out of that inconsistent state where the flight and the hotel have been booked, the car has not, and we want to consider rolling back those other 2 operations to return us to a consistent state. So Sagas provide us transaction management using a sequence of local transactions. So again, we're not using a global transaction against one data store. We now have those 4 independent in this scenario. Local transactions in a Saga is going to help us manage that sequence. And if one of the local transactions fails, then through the Saga pattern, we apply a compensating or a set of compensating transactions, right? We effectively undo, but that word compensating is core, or at least within the Saga terminology of, we compensate for the transactions or the part of the transactions that have been executed that then need to be cleaned up effectively in order to bring us back to a consistent state. So those compensations undo the changes that were made by the preceding local transactions. So if we add compensating activities or compensating operations in our prior diagram, to each of these services, we see the flight service now has certainly the book flight operation, but a companion operation for undo or unbook that flight. Hotel, similarly, for unbook the hotel, car, unbook the car, collect payment, refund that payment. So now the flight operation executes as the first step of the sequence, along with book hotel as the second step. And then we hit book car at the third step, and we get a failure for the car service, right, in its transaction with its local database. Well, now we can start to execute those compensating activities through that Saga pattern. And so step number 4 is now we're actually going to invoke the unbook hotel operation as part of the hotel service. And step 5 will invoke the unbook flight as part of the flight service. And that will return us to the ultimate consistent state, right? We wanted kind of the atomicity of that overall end-to-end operation. If any part of it failed, the whole thing should fail or effectively return to the original state before the transaction was even started. There's 2 primary approaches. Obviously, we've described Sagas at a logical level through the diagrams on the slides here, but there's 2 core approaches that are generally taken when implementing a Saga pattern in practice. And those are a choreographed approach or an orchestrated approach. And so choreography is more decentralized, where each service is responsible to reacting to events. It's very much an event-driven architecture. We're sending messages throughout the system, and each individual bit is responding to the messages that it needs to in order to take appropriate action, whether it's to book something or unbook something. But there's no central coordinator, and the services are loosely coupled. They're not bound to each other. An orchestrated approach does have a central coordinator. And so that coordinator service, often called the orchestrator, is responsible for directing that traffic, for saying which operations should be invoked and in what order. And it would handle both the sequence of booking those operations and detecting if something went wrong, making the decision to unbook those operations as well. There are benefits and drawbacks to each of these approaches. So for choreography, it's often manageable for smaller, simpler flows. It can get very complex. The more moving parts, the more components, the more messages, the more events that we share across these services in order to execute each individual bit of logic or undo that logic. But for benefits, there is no additional service. We just have those same 4 services that I've depicted in those prior diagrams, that flight, hotel, car, and payment. And they're working with each other. There's no single point of failure. Each of them is their own kind of fault domain. And they're communicating, again, over events or message queues to determine who should act next in the overall sequence or business process. But it is difficult to track which Saga participants listen to which commands. Each one of that has their own internal knowledge, but they don't know about each other. And it can often be confusing from a cognitive load perspective for reasoning about the environment and the application and developing and engineering about the order of operations, what is happening when, who's picking things up. It can be hard to add new steps. Imagine we wanted to add a boat booking service or a scooter booking service. And if we want to put that in between 2 prior steps, we have to rewire all of those events and the connectivity between each of those steps. And so that can be quite a bit of refactoring and challenging to do and to get right. There is a risk of cyclic dependencies, as some services could respond to events that communicate back to the same service that sent it, or that sequence, or that cycle of services in there. Testing can be challenging, as in order to end-to-end test, all the services must be running. And again, it can be quite difficult to monitor and debug the order of operations. You're often just looking at individual event logs. Maybe you're assigning correlation IDs to each individual request or each individual message, and you're piecing those back together, maybe through your logging and monitoring system. But it can be challenging to view and to see. For orchestration, again, benefits and drawbacks. It is a bit simpler to reason about, or easier to reason about, the more complex our flows get. So the more participants, the more obvious it is in terms of the order of operations, which action or which operation is taken in which in sequence. We can more easily add new participants. Again, if we wanted to slot in that boat booking or scooter booking or whatnot in between hotel and car, much more cleaner to wire that into the orchestrator and change the code there without modifying any of the contracts for any of the communication between the orchestrator and the individual services. There are no cyclic dependencies, so we don't have to worry about that. And the participants don't need to know about the other participants. All they need to know is when they're invoked by the coordinator that they do that work, and they return that work back to the coordinator, back to the orchestrator. But it does require this additional component, right? We now have to build this orchestrator. And so that becomes an additional point of failure in this process. And we have to implement that overall end-to-end coordination logic of that sequence of activities that happen. You might see, again, the drawbacks to both of those patterns, and our friends over at AWS and Azure see them as well. And they offer advice on their websites about the Saga pattern that at times just says, don't do it, right? Like this can be very, very complex to implement, and we recommend against it. It's difficult to debug from AWS's prescriptive guidance, they say. Complexity greatly increases with the number of microservices. It has a complex program model. Compensating transactions that we need to design for rolling back and undoing changes, they're hard, right? Azure similarly validates that opinion of AWS. I don't know which one came first. Maybe theirs did. But also challenging, hard to debug, a lot of complexity. You have to handle all kinds of transient failures. You have to implement strong observability in order for you to monitor and track and see these things. And overall, there are durability challenges with the Saga pattern when we kind of roll our own through those orchestrated or choreographed approaches. I'll pause there just since there are a number of folks that said you've worked with the Saga pattern, you implement a Saga pattern. Does that kind of resonate or not? I mean, have folks felt it to be challenging or complex at times, or have opinions, or have chosen more of a choreographed approach or an orchestrated approach in anything they've done? A little bit of head nodding. Nobody's brave enough to volunteer any direct experience with Saga. Cool. Well, I've seen this a lot in my development and teams I've worked with. That it's a necessary pattern that we need to be aware of in terms of, again, coordinating multi-step transactional processes through a series of local transactions, but suboptimal in terms of the overall complexity of it from a development perspective. And so that's where I want to position Temporal as a better way. So at the core, Temporal is not just a solution for Sagas. It is a solution for Sagas, but it's not just. There's more to what Temporal provides. And really, Temporal is a durable execution solution. And so Temporal guarantees that a business process, once it starts, will be driven to completion and give us the ability to do that through a simpler programming model, which drives our development velocity and productivity. We get that reliability of handling failures, implementing compensating transactions in a reliable and durable way, and we get really strong insight into the overall execution of an end-to-end business process. And we're going to see all of these things in the demo. But before we get there, just to introduce some of the core parts of a Temporal application, there's really two core sides to it. There's the application that we write with the Temporal SDK, and we have SDKs available, of course, in Java. Here we're talking about Java tonight, .NET, Python, TypeScript, JavaScript, Go, Ruby, PHP, which are not on that slide, but also available. And we get to take the approach, that very simplistic approach that we started with in this presentation of let's just write our business logic as if we were running in a non-distributed world, as if we were just running with a single application node, and we're going to execute sequential steps of booking that flight, hotel, car, and payment. So the programming model is quite simple. We'll see plenty of code to validate that and demonstrate that as we go. But the hard parts of distributed systems and state management and orchestration are now taken on by the temporal service. So a temporal application does require communication with a temporal service, the other part that we stand up. And the application communicates with the temporal service throughout its lifecycle to let the service know of the individual steps that have been executed, the state associated with those steps, if any steps fail, to coordinate retries, If any steps need to be delayed or you want to introduce timers or scheduled operations, it handles durably the time aspect of those steps, and overall orchestrating the individual steps through task queues. Temporal is 100% open source, MIT licensed. Both parts of this, the SDK side and the service side, you can write, run, operate in your own environment. I do work for Temporal, of course, and we also offer a commercial service for the right-hand side. So the service can be consumed through our managed SaaS offering as well, if you didn't want to roll your own. But again, everything we're talking about and we'll see tonight is 100% open source. To put that into the action, I've talked about the simplicity of the programming model, and this is pretty close to what it is. We'll get to see, live running code rather than code on a slide in just a moment. But imagine we have that book trip function with those 4 operations within it, and this function is running. Could be, depicted here on my laptop. Could be a server in our cloud environment or our data center, and this function starts to execute. And the first 2 operations in the function execute successfully, and we get to the book car line of our function execution, and imagine that process crashes. Again, whatever it is, whether it was a Linux server, Mac operating system, Kubernetes pod, Docker container, the process is dead. It's gone, right? The question becomes, with the simplicity of this code, what is the state of this system? How do we know which operations have been done? How do we know where the failure occurred? And what work is left to be completed for this operation to be, again, successfully run end-to-end, or this function to run end-to-end. Again, with this level of code, I have no indication of error handling, logging, or anything within it. The answer is we don't know, right? How would we know? But if this is a temporal application, Temporal knows, because Temporal is tracking the state of each of these steps and giving us the opportunity to resume execution at any point of failure. And this is the core of durable execution. And so as long as we can provision another process, a second Docker container, Kubernetes pod, virtual machine, Linux machine, Windows, Mac, whatever, that new process can pick up, it can resume the execution of this function from the point of failure and drive it to completion. And so if that initial trip get car, or I should say book car function failed, we can retry it again. Or if the process failed while that function was trying to execute, we can retry the entire process again on a new node. And this is a really powerful concept, that function execution can span process boundaries now. A function can start on one process, that process can die, the function running on that process can be halted and certainly stop making progress because of the death of that process, and then it can be resumed on a second process. And Temporal gives us that kind of superpower here. And so to contrast durable execution with just normal execution, what we're used to of our compute environments today as functions, there's lots of things that can prevent a function from executing successfully, right? A process can crash. It can be killed by the operating system. Machines can lose power. If you're in a physical data center, somebody can trip over a power cord. You might just be doing a new code deployment, right? You're going to roll through your entire Kubernetes pods. Each one of them is going to be restarted with new code. All in-flight transactions on those existing pods are going to die. And need to be resumed or repeated, in that normal execution world, but they're going to fail. And then transient failures can disrupt function execution. Networks can go down, processes can run out of memory, etc. With durable execution, we say it's crash proof, right? We handle, or the functions are guaranteed to complete and complete with consistency and correctness, despite any of those failures that can occur on the left-hand side. So Temporal itself is tracking that function state and handles the durability of function execution, even if processes crash, machines lose power, we deploy new code, or etc. And then to layer back in the Saga element of this, of course, that first tour through the code where we saw we had effectively a transient failure at that book car step. Well, we can also imagine that some of our failures are non-transient, right? That there might be a business level reason why we could not book a car, and then we need to effectively roll back or invoke those compensating actions as part of our Saga pattern. And this is the simplicity of the Saga pattern in Temporal. At the core, Temporal is an orchestrator, so it is aligned with kind of the orchestration side of the orchestration versus choreography. But what you don't see in this code at all, again, is sending events or messages over message queues to coordinate the next steps of execution. persisting state in a database to understand where everything is. Temporal does all that heavy lifting for you, so you can focus on your business logic. And I know in this case, if I within the try catch, I've isolated the collect payments step here. If the payment is not able to be processed because of a business reason, insufficient funds or something, well then I release the resources that I booked through the flight, hotel, and car operations. I undo each of those again to unwind the order of events and compensate, obviously, to have my clean Saga implementation at the end of the day. So let's move on from slides, and we'll see this in running code, and we'll get to see a little bit of temporal in action. All right, we'll lay that mic down in front. Hopefully that's audible enough for folks to hear. But let's go into our demo. So what I have here is, again, our trip booking application, fairly simple, where, on behalf of an end user, in this case Alice, we're going to book a flight, we're going to book a hotel, we're going to book a car. And so this is my front-end application that's running. And then on the right-hand side, and actually I need to restart it, but I will start my temporal server. So this is a temporal service that is responsible for orchestrating the steps of execution and handling state management and reliability and durability of operations. Temporal can be run entirely locally. Again, all open source. In fact, we can brew install Temporal if you're on a Mac, or download the binary if you're on Windows or Linux. And then once you have that binary locally, we can start up that local server. And so now I have a local temporal server that is running and that is ready to participate in the execution and the durable execution of an overall end-to-end business process. My UI application at this point is wired to talk to the temporal server. So if I go, oops, I haven't started the UI. If I go and execute, let me go back. That book tripping operation, what we see is an event or a message. In this case, there's two because I started in parallel to do that failure. There's two running functions that Temporal knows about. And again, in Temporal, we call the core function a workflow function. And so the UI application has now communicated with the Temporal service to say, please execute and coordinate the execution durably of a book tripping function. And so we have that function that is ready for all of the individual steps to be processed and executed of this function. However, there's no progress being made right now because I haven't started the actual temporal application. All I've started is this front-end UI with some HTML and some Python, but we need to start the Java application. Before I do so, just like, what does that Java application look like? I've been talking about its kind of standard Java code, idiomatic Java code, to temporal power or enable an application. We're just using the temporal SDK on our application side. And so this is what my build.gradle file looks like. And it should be obviously very familiar to folks, with Gradle. And obviously there'd be equivalent in Maven or other build tooling and chains. But we're just introducing a dependency into our application of the temporal SDK. And so that's it. As simple as bringing the SDK into my application now gives me the ability to write and workflow functions or annotate existing Java functions to be workflow functions where we start to coordinate the orchestration of the steps of this business process. Once I bring that library in, again, I can start adding those annotations to our typical Java code. And so a workflow function in temporal Java is just an interface annotated with the workflow annotation. And that core workflow method is annotated with the workflow method annotation. And so that's our book trip implementation. Or the implementation of that, of the book workflow, is now, again, also kind of fairly standard Java code. I'll come back to the Saga implementation in a minute. But we see that it's just, in this case, simplistically, a sequence of function calls. We're going to call a function to book a flight. We're going to call a function to book a hotel. We're going to call a function to book a car. In this case, instead of collecting payment, I just sent out a notification to user. But we're the same 4 steps of our function. And again, ignoring for the moment, the sleep, which is just a pause for dramatic effect in the demo, and we'll come back to the Saga implementation. But my temporal code is just to book these three, or execute these three activities, booking activities in order, followed by the notification activity as well. All right. Again, we have within the temporal service, it has captured the intent to run a function, but we don't have this actually temporal application running yet. So that will be the last bit here. We call, just in temporal terminology, the application that is going to do the work, the worker. So again, this is just a standard Java application. In fact, if we just take a look at the start worker command, it's just invoking our Gradle run, which back to our Gradle file is just the main class of this application. All right, so we will start that worker process. And now that worker will communicate with the temporal service and start picking up the work and executing the work and delivering results back to that temporal service. And we can see this, this happened here in terms of each of those individual operations. Now this is a bit drawn out or a bit stretched out because of the time delay of me not starting the workers and this slowing down, but let's run this through one more time for a little bit of a compacted view so that we can cleanly and concisely see the visualization and just the observability that we get right out of the gate with temporal, right? Each of these individual functions that we expressed in code, this book flight function, hotel function, car function, and user notification, are implemented or are powered by the temporal SDK. And individual functions within temporal workflow, the steps of workflow, we call activities. And so that's why they're all kind of invoked off of an activities object here. Again, the definition of these activities is just pure Java code. We have an activity interface, which we annotate from a temporal perspective, with the activity interface annotation, as well as the individual methods. And this tells temporal now to start tracking the state of these methods as they're invoked by the main workflow. The implementation of these methods, again, is now just pure Java. I can write, any code that I'd like to within the flight booking method. I have the full capability of every other library dependency function within Java in order to execute my business case. So, we talk about temporal in the concept of workflows and as a kind of a durable execution solution, or sometimes some folks will say a workflow as code or a durable workflow solution. But we just get to write our native Java imperative code as we need to express our business logic and to implement the functionality of our app. It's all 100% code with this kind of minimal introduction of the temporal SDK through, in the Java case, annotations here. So with, again, the simplicity of that level of kind of integration with Java SDK, we get a lot of powerful things right out of the gate. The first is this level of observability, right? We can clearly see each step of this function as it is running on that worker process. So we see that the book flight operation occurred, followed by a little bit of a timer, a delay for a dramatic effect or a dramatic pause that I put in there, but followed by book hotel, book car, and notify user. We have the event log or the event history of all of these operations within temporal that give us insight into not only the operations, but what were the individual inputs that were passed to each one of these functions, how long that function took to run, what the results were, and the outputs or the responses that were carried back from temporal in each of those steps. There's a lot more in terms of the overall verbosity. The execution of this application is, again, a coordinated set of steps or that happen between the workflow function and the activity function, and we can see all of the individual sequence or steps of execution for the workflow function as well. This can be quite a bit to look at, but certainly powerful for the temporal engineer, for the temporal developer to determine when was the workflow function executing versus when was the activity function executing, and what other temporal primitives like timers were involved in the overall execution of this. Again, these are great and powerful tools for debugging and observability about what happens during the end-to-end processing of temporal application. So we've touched on a little bit of kind of some of the value prop that I mentioned of temporal early on in the slides. The development velocity, right? We're writing kind of clean, simple code. There's not a whole lot to it. We're not this code. We'll get to the catch down here in the end, but each of these individual steps are not encumbered by heavy error handling or processing or logging. Temporal's handling a lot of that from us. And that first core step of kind of durability and reliability that we get with the simplicity of code, I can demonstrate by doing that process crash that we talked about before in those slides. So to see that in action, what happens if in the middle of a trip booking operation, the process that is running that function crashes. And so we'll start off by running that, and then I'm just going to hard crash that, Control C this process. Of course, we have some logging there, so we can take a peek at the logging. We see, okay, that a workflow function started, we booked a flight, then we were waiting, and before the next step of this process happened. From a normal execution, right, a non-durable execution perspective, this process is dead. Again, back to this code. This code isn't explicitly storing state, not handling retries or resumption or rehydration of this process in any way in order to resume this for a successful end-to-end execution. But Temporal is, and if we go back to the Temporal dashboard and we take a look at the workflows, Temporal knows there is a workflow function that is running. It hasn't finished yet. And in fact, there's no active progress on the work of this function. We've tried to tell a worker to pick up some bit of work to continue execution of this function, and there's no worker that's available right now to pick it up. So we're just going to sit here and we're going to retry. But we're going to hold on to all the state of this function. We're going to hold on to the fact that a flight has already been booked, and that the hotel is the next thing that needs to happen in this operation until a new worker is provisioned to resume this function. And so I'll come back and I'll start that second worker process. And within obviously milliseconds there, we can see now this has picked up that exact function execution from its point of failure, completed that step, as well as the following steps to book car and notify user. So just that demonstration or that bit in action of function execution spanning process boundaries. We started a function on one process, that function crashed, that function was resumed from the exact point of failure with all of the prior state preserved for the previous completed steps, and then that drove the execution of the subsequent steps of that end-to-end process. And from my UI perspective, I return the full result. And so while there was a delay in this result, of being returned to the end user at the other side of this operation has no idea, that there was this transient failure, right? This process crash that happened in the middle of their book tripping operation. They weren't first to go back and rebook the trip. We didn't bubble up an error to the user to say, sorry, this process failed. You go resubmit it, please. We just held on to the context of the state that was executed successfully and continued that operation when a new process was available to do so. So that's the core of durable execution. Of course, Temporal has a lot of other features and capabilities to help us handle kind of both transient and non-transient errors. And so the next thing I'll do is imagine that one of the sequence of steps in our execution is kind of we're invoking an upstream API, in this case, the flight booking API, when we were calling an external service instead of a database, and that external service is flaky. And so we'll put in the flaky airline booking flight number, and we'll come back. We'll see a workflow has been started, of course, for that. But that operation to book the flight is currently failing. And we get, again, this direct visibility within the Temporal UI. In fact, can make this a little bit bigger and easier on the eyes through this pending activity views. But the booking service is experiencing some unavailability. And so the operation is not succeeding. We see logging to that effect around exceptions being thrown in the logs, but Temporal through the UI is telling us as well that this operation is failing, but I'm going to keep trying. And I'm going to try this effectively an unlimited number of times. And ultimately, in this case, just as I was on that page, the operation succeeded. So we had some sort of transient failure for which this API was failing, for about a minute worth of time there, but it ultimately succeeded. And Temporal, again, just held on to the context and held on to the state of the end-to-end workflow, and through its automatic retry policy, continued to retry that operation until it was successful. Now, I'm sure folks have implemented retry policies and libraries as part of their other applications. And so in that sense, there's a similarity to what Temporal is providing out of the box to those other things, except that, again, now everything within Temporal is durable. If I had crashed this application, this process during that retry, I would have resumed retrying from the last retry kind of point. Versus if you're using like just a retry library as part of your application and you have a retry policy, in this case, this is our temporal retry policy that we're expressing here. We're saying our retry options for these operations are to start our first retry at an interval of 1 second after failure, to back off each subsequent retry by a factor of 2. So we'll go from 1 second to 2 second to 4 second to 8 second, up to a maximum number of retries. But temporal durably holds that retry context as well, right? So if the process were to crash after 5 retries, we'd restart the process. It's not going to go back and start the retry storm from the beginning. It's going to start the retry on the 6th attempt of the retry, right? So we're appropriately backing off. And again, that function execution with that retry is spanning those process boundaries. The next thing that temporal gives us that, in fact, there's no other framework that I've worked with has, is the ability to kind of fix issues or bugs in our code for, again, a running function and then drive that function to completion. So in this case, I'm going to start a new workflow function, but now with a buggy implementation, or it's going to invoke a buggy implementation of my book hotel method. So we're going to book that trip. That's going to start a new workflow function in temporal. Temporal is going to show us that function is executing. And in this case, I was quite explicit, of course, helps me in demo to pinpoint the area of the code, but there's an error due to the bug in the code. And we can see it's right here on the book hotel line at line 45 of our Java file. And again, our retry policies have kicked in. Temporal has a retry policy that is for this that we've configured for this function to be unlimited with that exponential backoff. So this is going to keep trying. It's going to hold on to the state of all the work that's been done for this business process. Again, we're not going to lose the state that book flight has been completed. But if we can fix the book hotel, we'll just continue on from that point in time. So again, back to my application, I'm just going to shut down the application. It's not doing any meaningful work right now. It's stuck on this retry to do this buggy code. And I'm going to go into that editor and find line 45 of that file as we talked about. And I can see, oh, of course, there's clearly a bug in this code. I wish all bugs were this easy to fix. I'm going to flip the bug boolean from true to false. And so now we've resolved our bug in our code. And we can go and we can build and deploy that code, right? I can do my Gradle build and my subsequent Gradle run, to start this worker or this Gradle application. And now, once that application is back up and running with the clean code, Temporal picks up that function from that point of failure, even though that point of failure was introduced by me as a developer and the engineer. And I've resolved that, and it continues execution of this end-to-end business process. Despite that transient failure, but despite that disruption of the code. Again, super powerful concept, right? Like we've all written software that has error conditions, boundary conditions, edge conditions that expose themselves, at the worst times in the worst ways in our production environment, right? And I'm sure many of you have been in kind of those war rooms and those huddles. It's like, okay, we got to fix this code and we got to roll out that change, but what does it do to all the processes that were in flight? How do we reconcile that? Who do we need from the database team to clean up the database tables? Who do we need from the message queuing team to handle dead letter queues or messages on those queues? None of that needs to be done with Temporal, right? We don't have to manually reconcile a cleanup state. Temporal knows the state, it knows the status. We fixed the code, we rolled it out, and we drove that function to completion. The final demo scenario is really the core of tonight's talk, is what we've seen in these prior demo scenarios, just setting the stage, are transient failures, right? Processes crash, processes come back up. That's a transient failure. APIs go down. That flight booking API was unavailable. It eventually came back up as a transient failure. Even my code execution with a bug in it was a transient failure because I was able to fix that and reapply or redeploy my code. But there are failures that we cannot recover from, right? Those business level conditions. And so this brings us, to our Saga implementation. So with Temporal, all errors like by default that might be thrown or come from an activity, a step in the overall process, an activity function, are what we call effectively retriable. So things like runtime exception, standard Java exception is going to be retriable, right? So that's why we were able to, ultimately book that flight despite the fact that the API was down for the first six attempts, or we were able to retry this function after fixing the code because it's a retriable error. But there are errors, again, from a business perspective that are non-retriable, right? And in this case is, imagine we're trying to book a car, which and we maybe miss some validation up front in the UI, and we get bad data that's passed into the backend. The backend just simply can't do anything with that data. It's junk data, and so in this case, that book car will never succeed with junk data, and this is something that we should just not retry. It's not meaningful in any way for us to continue to retry in an unlimited fashion this function. So we throw, based upon this condition, a non-retriable failure. And this non-retriable failure is going to be caught by our catch clause in our try catch. And now it's going to execute, standard try catch functionality. And this is where we wire in, or we return to the wiring in of all of these operations in our Saga pattern. So within Temporal, there is a specific Temporal primitive, a class called a Saga class in the Java SDK. And so we've imported that workflow Saga class in Temporal. And at the beginning of the execution of this book tripping function, we instantiate that class. And we set some options for how we're going to execute the compensating activities, so compensations. We could execute them in parallel, or we could execute them sequentially. In this case, I'm turning parallel execution off for the compensations. We're going to execute them one by one. But now this is the Saga object that is going to hold on to the compensating activities as we build or as we execute the individual steps of the operation. So when we book a flight through that first activities book flight call, after successfully booking that flight, we're going to add a compensation to the compensation list that will allow us to invoke the compensating activity, the undo operation for booking that flight. This is a preemptive, kind of a defensive coding mechanism in that we don't know at this point if there is going to be a failure or not. We don't know if we'll have to actually execute the compensation, but we're going to hold on to the compensating activity, or we're going to put it on the list for compensating activities to be executed in case there is a failure, right? What do we need to undo in order to return the system to its consistent state? After we book the hotel, we're going to add the undo book hotel activity to the compensation list. Likewise, after we book the car, we're going to add the undo book car to the compensation list. And finally, notification doesn't have an undo equivalent to it. It's just a notification. You can't take it back at that point if something goes wrong after the notification. That email message or SMS goes out. But if any of these operations should throw a non-retriable error, which is effectively in Temporal world identified by this or handled by this activity failure class, then I'm going to execute the compensate method of our Saga class. And this is in reverse order going to execute the undo operations that have been added to the list, again, kind of preemptively through the code on line 46, 51, and 56. So let's finally see this in action. And so for my car operation, again, I'm going to pass in that bad data. It's going to magically get through the front end validation. Unfortunately, I didn't do a great job of my validation and form validation on the front end. We send this through to book trip, and this starts a new workflow. And this workflow, of course, is now running, but we see a different pattern of execution as compared to all those original workflows. In this case, that book car operation failed, right? There was an invalid data. This is a non-retriable error. There's nothing we could do with it except for handle it in code. And now we see our compensations that have been added to that list get executed in that reverse order, right? That undo book hotel is the companion or compensating activity to book hotel. So that data and that system is cleaned up and made consistent. Undo book flight is executed as the compensating activity for book flight. So we return the environment and the application to a consistent state by using that Saga pattern. But again, without the complexity of either a DIY choreographed or orchestrated Saga. If I look at this code and I return back to AWS's prescriptive guidance and Azure's guidance, I'm like, what are you guys talking about in terms of Saga should be avoided based on complexity? This is fairly simple and straightforward to do, right? As dead simple as it gets to write code to execute operations and then to add compensating activities to a Saga class to undo those operations in the event of failure. So that's the core of the demo. Happy to take any questions, whether related to slides or the demo itself. Yeah.
So, is it possible to run actually activities in parallel? And
Yes, absolutely. So the question was for the audience and the stream, can we run activities in parallel? And 100%. So yeah, I've for the simplicity of the demo, I have I've made all these activities effectively synchronous operations. Now they're all being coordinated through the temporal service. So Book Hotel actually sends an event to the temporal service to schedule an activity to be run, and the worker picks it up. But I wait for the result to come back. In Temporal, I have the ability to invoke an activity directly like this in a synchronous fashion, or there is effectively an asynchronous invocation. I can call an asynchronous kind of function primitive to invoke this in an asynchronous way, and then not block on the result. And instead of giving me a string result for this activity, it will give me a promise, for a string, right? And so this is effectively a way for me to now invoke each individual activity and set it off asynchronously, and then at some point later in time, so I could do that for each of flight, hotel, and car. I could do all of them as asynchronous function invocations returning promises. And then I have there's, I don't know the exact class off the top of my head, but there's effectively like a wait for, and I can pass in like all the promises that I've gathered from the prior function execution. So absolutely. So we can fan out very easily in Temporal, invoke functions synchronously, invoke them asynchronously, define later on in our processing when we want to wait for the results of those things that were done asynchronously, and execute that parallel execution pattern that you asked. Yeah.
And another question.
Yeah.
In this case you showed right now, user is waiting for the answer, so it's like a synchronous process. But still, it's like I think no, we can schedule and run more workers than once. So in your case, it's workers like in a part of a backend API. So I'm not sure it's the best way to do it, or how. In other words, how we to execute this synchronous way and wait for the result of the worker that actually.
That would be great. I think there's a couple questions in there, so I'll touch on a few of them. One is, let me just clean up my garbage pseudocode here. Is I am executing this on a single worker, but this could be absolutely a pool of workers where the work is distributed across a pool, right? So that is as simple as me just starting multiple workers. I'm just going to start now 3 here on this screen. And so now I have 3 horizontally scaled distributed worker processes. Obviously, they're all running on my laptop right now, but they could be running on different Kubernetes pods, different virtual machines in my data center. And let me just clear the log. So hopefully we get to see some fun distribution of the tasks across a set of workers. And I'll go back to my UI, and we'll have a clean execution of book tripping. And so now we see individual steps of this overall process handled by discretely independent components, right? Obviously, all these workers have the same code base, the same build, but the top worker is handling some of our workflow function method invocation. This middle worker picked up the flight booking and the notify user activities. The bottom worker picked up the hotel and the car activities, right? So we've done now distributed tasks across a fleet of workers. So I think that was part of your question. The other part of your question is, well, your UI is maybe suboptimal in that it's blocking and waiting for the result of all this work to be done, right? So the work is orchestrated by the workflow function, regardless of how many worker participants are in here. Like, we demoed 1, we demoed 3. I could make this, 7, 7,000, whatever it is. All of these folks are doing work that's being orchestrated by the workflow function through the temporal service. And then ultimately, when the workflow function is complete, it sends the result, back to the temporal service, right? We get, the completed result of the workflow, that's recorded by the temporal service, and then the front end application has a temporal client through which it can retrieve the result of the workflow. And I have just for very simple demonstration purposes, I've made that client sit and wait in a synchronous blocking fashion for the result of the workflow. That was just a demo design decision I made. I can bring up the UI code. We'll do it in a different editor here. This is now not Java. So apologies to the jug, but we all write polyglot applications and other languages. And so my front end application is a very simple Python application. This is where it has a temporal client that allows this application to communicate with the temporal service, both to start a workflow and potentially retrieve the workflow result at a later point in time, right? So I can get that result whenever I need it, but I don't have to wait in my UI application. And I didn't even do anything as UI, but like the reality is like the whole, you probably saw the browser, wheel it's just waiting. The browser's just, through the Python API, just waiting on the response to come back because I have chosen to make this call as a synchronous blocking call. But everything in Temporal World can be done asynchronously as you want. And then you can just later return results through either promises or handles on the workflow when the result is ready. Great questions. Yeah, another question.
Okay, my question is, because those workflows are durable, I'm guessing you are serializing their inputs and outputs. And how does it work? Like, how do they serialize? And what happens to the exceptions? Like, can you serialize an exception?
Yeah, great question. So, so the context was, in the durable execution and the orchestration of the function through the temporal service, the individual inputs and outputs of the functions and the steps of the functions are stored as state in the service, and they must be serialized into the service. So how does that work? And so that works by default for any type in the Java language that is serializable to JSON, right? So there is a default, there's a component that we don't see here, but which absolutely exists in the temporal SDK, is that anytime we invoke this book flight activity method, and remember, this activity method is annotated, right, by a temporal annotation, right? This is like kind of temporal level code that we see. The core of our method, for book flight just takes a string as an input and returns a string as an output. But this could be a more complex type. It could be an object, it could be a POJO, it could be something like that. As long as those inputs and outputs are serializable to JSON, and we use, by default, the SDK uses the Jackson serializer for JSON, it knows that this is an activity method, that these parameters and these results need to be serialized as part of, and it will perform the default serialization on the wire as we make that method invocation, or as that method invocation is orchestrated by the temporal service. So the payloads cross the wire, they absolutely end up within the temporal service, right? We go to book flight and we can see the string input that was provided, and we can see the string result that was, and now these are bracketed in JSON, right? What we're displaying in the UI is JSON, and that has just happened by default. So there's a default serialization implementation. You as a developer are not confronted with it until or unless you get to a far more complex type that does not have an out-of-the-box serialization routine in the Jackson library, right? And that you can encounter. You can create some sort of complex object with hash maps and keys and other things that might not be default serializable. And then what you do is you just write your own, serialization class. In terms of like my input here, for this is the book trip input that's being passed into the workflow. I'm just using Lombok to obviously remove the boilerplate. But I can use, if I had some sort of complex object, I could use like Jackson serialization annotations here to identify how this should be serialized in Jackson. And so I end up writing that code to augment the default serialization capabilities. Awesome questions. That was great. Any other questions from anyone else? Yeah. can we use Temporal along with Spark jobs?
And then Spark goes with everyone. I can see that.
Yeah, so I've never used Spark myself, so I'll just like lay that out there. I don't know all the details, but an activity function in Temporal is just pure Java code. Any Java code you can write and run in any Java application can be run within an activity function. So there's no limitations to the type of code or the systems we integrate with within a temporal activity function. So if yes, that activity function could spawn using a client or a connection to an external service, another job type, asynchronously, synchronously, it could wait for the results. It could not wait for the result and check on it, the result through a second activity later on at a point in time. I don't know exactly what pattern that would be most applicable with Spark there, but absolutely we could, if you can call Spark from a Java main method, you can call Spark from a temporal activity method. All right, yeah, let us know. Yeah, cool.
Okay. And we have a question from the online attendees.
Perfect.
Okay. So Mikhail is asking this question. Is it possible to add temporal to existing microservices, for example, written in Spring Boot, let's say in Kotlin from SDK's point of view and starters?
Yeah, absolutely. So Temporal has a Spring Boot starter. I didn't want to assume Spring Boot knowledge by everybody in the session here tonight,
Yeah.
so I chose to just go plain Java for Temporal. The core part of that, well, there's a bunch of aspects to the Spring Boot starter that help us integrate with the Spring Boot application. But one of the core things that I haven't shown up to this point is the main application, which starts up the worker process. And so, Java can be verbose. We love its verbosity at times. We work against it maybe at other times, but as compared to other languages. But the thing about Temporal is we try to be very idiomatic to the language for that SDK. So the way we create a worker process in Java is not going to be the exact same way we create a worker process in Go, because Java and Go are different, and so Java, has patterns of creating services and stubs and builders and the builder patterns and things of that nature. And so, this code, again, I just say verbosity because there's a few more lines in this code than if I write Go code, to create a worker, but it's obviously idiomatic and natural to Java. So we create this, we create the service connection to our service endpoint, and we create our client. We have a factory for creating new workers, and then ultimately we create this worker. And then in Temporal, we register the workflow function and the activity functions that can be processed by this worker, and ultimately we start that worker process. All right, so that's a bunch of boilerplate that needs to happen as part of a Java main method for Temporal. But if we look at, actually, I just have a link probably to the Temporal SDK. There is, in addition to some Kotlin utilities and helpers there, we have the Spring Boot starter and the Spring Boot auto configuration. So to the question that was asked, can we integrate cleanly, nicely, idiomatically with Spring Boot, to leverage the power of boot and dependency injection and automatic configuration, and absolutely. I just didn't do it in the code here today, but our Spring Boot apps in our main methods become a whole lot simpler, without that boilerplate, because we just end up handling that through the Spring Boot configuration of our target endpoints and things of that nature. I think the other part of the question is, can we introduce Temporal into an existing application or set of microservices? And the answer for that is yes as well. Temporal is not just for greenfield development. It's not just from building a new application from scratch. We can leverage Temporal within an existing application environment. And much like a kind of monolith strangling pattern, or we can approach our use of Temporal in slices of the application where Temporal is going to give us the most benefits. So we don't have to rewrite the application in any big bang way. If we can find 2 or more steps in an overall business process that would benefit from Temporal's reliability, durability, observability, we can make those steps a workflow function. Now, you are going to end up changing the way that those 2 microservices communicate today. So you have 2 microservices as part of like a fleet of microservices. Maybe you got 10 in your business process, and now there's 2 that we want to participate, or we want Temporal to kind of wrap the execution of. Well, if they coordinate through events today, they coordinate through Kafka, right? If they're sending messages to each other, we rip that part out, right? Now they're not sending messages to each other. They're just invoking activity functions and workflow functions that are orchestrated through the temporal service. And then our microservice workers are picking up those function tasks and executing those functions, right? So we end up going, it depends on how your microservices are working, but potentially from a choreographed model of those 10 microservices to an orchestrated model of those 10 microservices, or 2 out of the 10 to start with. Or if you have more of a synchronous like REST API based communication model between those 2 microservices, well, again, we rip out that REST API endpoint and we make the first microservices invoke a start workflow on the temporal service, and we make the second microservice as a worker that consumes the workflow task off of the temporal task queue, right, in order to execute it. So there's lots of patterns for moving either from choreographed microservices to temporal or orchestrated microservices to temporal, of using Kafka in your microservices, using REST API communications, whatever your coordination patterns are. There's an opportunity for temporal to help simplify that, and for us to do it kind of pragmatically and in small steps rather than a big bang operation. Great question. Yeah. So the question, if folks didn't hear, was, does this overall increase the response time? And the answer is yes. Yeah, absolutely. I wouldn't say it's a heavy price to pay, but sure, the price we pay for this durability of execution comes with increased latency, because each one of these individual steps, not only invoking the trip booking workflow as a top level workflow function, but now each of these individual steps is coordinated through the temporal service. So book flight and book hotel, and as we saw in our multi-worker process implementation, may not be happening in the same process, right? So there's no local communication between those 2 functions. Their function, the intent to execute the function along with the inputs and the outputs is all going through the temporal service, and all of that carries an extra latency overhead, right? On the order of 20, 30, 40 milliseconds, right? Depending on what it is. So if I have a 4-step process and each one of those is adding the overhead of temporal is 40 milliseconds, while my end-to-end trip booking function just takes now 160 milliseconds more than what it took prior, right? But yeah, absolutely, yeah. But with that penalty, and again, in the majority of use cases, it's a non-issue. A user isn't necessarily going to know the difference between 160 milliseconds on this. But with that overhead, we get the benefits of all of the durability and failure, fault tolerance, and reliability of temporal.
Okay, I just have to ask this question. Everything is AI now, right?
Yeah.
So is there any work being done in terms of, I see too, let's say using agents, right? I mean, is it supported yet?
Yeah.
Like temporal to work with agents, AI agents?
Absolutely.
Yeah.
And so, yeah, the question was just, what is temporal's relationship with AI? Can it help? And so AI is obviously an exploding use case for us all, right? Like every software engineer is becoming an agent engineer. Like we're all becoming AI engineers. Our businesses are adopting, embracing AI, and we're all working towards figuring out how to write those applications that do that. All right. There's also a number of emerging AI frameworks and libraries out there, and I'm sure you've all heard a lot of them. Like LangChain, LangGraph, CrewAI, the OpenAI SDK. Other LLM providers have their own SDKs. Your typical agentic application is a distributed system, in fact, in the sense that there are multiple components that are interacting together, right? I might be calling multiple LLMs. I might be feeding the result of one model into another model. I might be interacting with a RAG, a vector database for retrieval augmented generation. I might be calling an MCP server, right, to get additional context. These are all distributed systems calls at the end of the day that you as the developer are orchestrating. right? And so that's where we see like Temporal being an amazing fit for AI, because the hardest problem in distributed systems is the reliability in the orchestration of these systems, right? Having said that, we're also hyper-focused on the developer experience, right? A big part of the birth, the evolution of the Temporal platform from our co-founders, Maxime Fativ and Samar Abbas, is providing a great developer experience for distributed systems developers. And we want to elevate the development experience for AI engineers and AI software developers as well. And so while our Python SDK doesn't yet have like primitives for agent call, LLM call, MCP call, we do intend to like layer those things in and build those on, right? So so not only do you get the strength of the core of Temporal for reliable execution in a distributed system environment, of which all AI applications are, we also get like the developer primitives, that accelerate prototyping and developing around AI applications as well. But we believe we're the best AI platform at scale with reliability at scale. Like all of the emerging frameworks, they're great, like and to be determined what level of scale they can achieve, because they're also new and nascent, right? Nobody's proven out that any of these frameworks can handle 1 million users in like a minute or an hour, right? Temporal can, right? Like we scale out to yes, hundreds of thousands of activities per second, of actions per second in our platform, and actually, I'll say, and OpenAI has been public about it. OpenAI is a big user of Temporal themselves. They have a lot of their features and functionality that are user-facing that are powered by Temporal, and they benefit from the reliability and durability of Temporal. So there a number of the frontier and foundational model providers are leveraging Temporal, their own engineers, in terms of what they're building and providing for their customers.
Oh, cool. Cool. Okay. Right.
Awesome.
I guess it's good.
Well, if there's no other questions, I'll leave you all with just a couple quick takeaways. One, you can take a screenshot. I can make the slides available to Mary. We can post them out there. But if you're looking to get started with Temporal, we have some great free online courses. There's more than just 101 and 102, but get started there. There's about 6 or 7 courses out there for every individual language and SDK. There's all kinds of samples for different types of patterns and applications in Temporal. Standard documentation, of course, in the developer guide. And then we have an incredibly active Slack community. So please, if you're interested, join the Temporal Slack. The Java SDK channel would be specific to Java SDK questions, but there's all kinds of channels you can join. And then finally, there's a lot going on at Temporal this summer between our marketing and developer relations and advocacy and field teams around webinars and meetups, and they're doing online trivia where they're giving away prizes and scavenger hunts. And so snap the QR code if you're interested, connect with the team. We're calling it Space Camp. I'll be honest, I don't even know 100% why it's called Space Camp. Last year it was Summer Camp, which certainly made sense. It was summer. We did send our mascot Ziggy to space last year as part of a durability demo where we had a Python application that was launched out of the atmosphere into space, and it came back and it kept running. And so with Temporal, so that was fun and one of the highlights of our user conference. But anyway, June 5th to August 31st is Space Camp, and there's lots of ways you can participate and win some cool swag and prizes and other things there. So
okay, yeah, great. Thank you.
All right, you're welcome. Thank you all.
Thank you. Yeah, okay. Yeah. And we'll do the raffle. I think we have 5 people enter into that. And let me quickly do this. And okay. Oops. Okay. So if you still like to enter into this raffle, we have 2 JetBrains licenses to give out. So we have Mikael, Benjamin, Serafima, Aditya, and Stan. So good. Yeah. Did you enter? Did you like to enter? Okay. Yeah. What is your name? Yeah. You should still fill out that form so I have your email if you win. Yeah. Hi. Yeah.
K-A-T.
Anika? Yeah. Okay.
Thank you.
Okay, that's good. Yeah. Okay. Good. Everybody's good. Okay. I'm gonna draw two names. Okay. Two times. And do you mind checking online on the stream too, just in case, to make sure nobody? Oh, good, right? Okay. All right. Let me do it. Actually. Okay. Okay, Seraphima. Is Seraphima here? No? I guess. All right, that's the rule too, is that you have to be here. Yeah. Can you She left? Oh, that was the lady, right? Oh, that's too bad. All right, well, that's it. You have to be here. I forgot to remind folks. Yeah. Okay. It's not somebody online, right? Yeah. Nobody says. Okay. All right. I guess we'll remove, and we'll basically increase the probability of winning for the remaining 5 participants. So okay, we have Stan. I know Stan has asked about it. Yeah, so Stan is online, right? Yeah, Stan should be. Okay, cool. We have Stan. Okay, one more. Okay. We have Benjamin. Is Benjamin online? Yeah, and Benjamin should be online, I think, right? Can you answer me, Benjamin? And I know him too. He's in Germany. So, yeah, yeah. Did he answer?
Stan respond.
Yeah.
Saying that he's online.
He's online, yeah.
Maybe it's 10-second delay, so if
Okay, all right. We wait a little bit. So Benjamin is.
he's online.
Benjamin should be online. He's in Germany. Yeah, yeah. He and I was exchanging messages. So, but is he responding?
The member count is still.
It's still there. Okay, yeah. All right. So that's Benjamin. So anyway, but thank you. So I have Stan and Benjamin, the winners. So yeah, thank you again. And but try again. We'll have more meetups too. As I mentioned, in July, it should be the 24th. We have the lightning talks. So and thank you again, everybody, for attending. Okay. All right. Have a good evening. You can still hang out for a little bit too. Thank you. All right. Thank you. Thank you, Peter. Yeah. Thank you.